In today's episode, we're going to explore the evolution of autopilots, how they've become a staple in light aircraft, and the ups and downs of relying on them. All that and more coming right up. So strap in and let's get into it.
Standby star 9000, 1013, KFI 25. Coordinating aileron and rudder, bank, balance, bank pressure rolling at 30 degrees. That's 30 degrees there. $3 runway 29 1231.
G'day everyone and welcome to episode 126 of Flight Training Australia podcast. From Canada to New Zealand, Singapore to Australia and everywhere in between. This is the podcast all about flight training and flying in Australia and beyond. I'm your host Trent Robinson. G'day. Thanks for tuning in and joining me. How you going? I hope you've had a wonderful week. It's been busy and hectic as always. The weather's getting a bit nicer, not quite so hot and sweaty up here. But plenty happening, and it's been fantastic to hear from so many of you. I've been running into people all over the place at the shops, at the airstrips around the airport, that sort of thing, and catching up with some of you, finding out what you're up to, where you've been, and hearing from people I haven't seen in a long time as well, listening on the way to work and whatever else. So if that is you, it was great to see you all and to hear from you. Thanks for all the messages, and please keep them coming. I really do love hearing from you all and seeing where everyone's up to and what's going on. Big episode. Talked about autopilots the other week, and I promised you I would talk about them again soon. And so here we are. And a fascinating world of autopilots and light aeroplanes. The systems and equipment that we've got now rival that of the big airliners. They really are phenomenally capable, and when used properly, a pleasure to use. And what I want to get into today is really just have a bit of a look at the historical roots of autopilots and where they've come from, how we've got to where we are today, and explore every twist and turn. Get it? Because there's knobs you twist, and anyway. All right, so autopilots, interesting past. As we said, how far back do you think autopilots started? It's a lot further than you might have thought. In 1912, a visionary inventor by the name of Lawrence Sperry made history with inventing the world's first autopilot. So not even 10 years after the Wright brothers' first flight. It's quite remarkable. Inspiration coming from the challenges of maintaining stable flight, especially during long journeys, Lawrence set out to revolutionize aviation with a groundbreaking invention, the gyroscopic autopilot. So that was a gyroscopic autopilot utilizing, you guessed it, gyroscopes to detect and counteract aircraft movements, effectively stabilizing flight without direct pilot control. So this innovation obviously was a game changer, offering pilots new freedoms, constant manual control, significantly reducing pilot workload, which is the whole idea, right? Well, it is until it isn't. Let's have a look at quite a famous incident or accident. Well, it's both, isn't it? It's an accident that happened in June 2009, and that is the Air France flight 447. So if you're not familiar with that one, that was an Airbus A330 en route from Rio de Janeiro to Paris, encountering severe weather, thunderstorms over the Atlantic Ocean. It entered some thunderstorms, experienced a series of technical failures, including the loss of airspeed indications due to icing and then the disengagement of the autopilot. This created a bunch of confusion on the cockpit, the flight crew struggling to regain control manually. And despite all the sophistication and the autopilot systems on board, the pilots made inappropriate control inputs, exacerbating the situation. Tragically, Flight 447 plunged into the ocean, claiming the lives of all 228 people on board. And there have been other similar accidents and incidents resulting in confusion, over-reliance on automation, and the loss of control. So this flight 447 accident really serves as a sobering reminder of the critical importance of proper autopilot usage and pilot training in its use. Inadequate understanding of the autopilot's capabilities, coupled with a lack of situational awareness, can have devastating consequences. And it does absolutely underscore the need for pilots to undergo thorough training, including scenarios involving the autopilot failure and manual flight control, as well as its normal use. And this, as always, comes back to my old friend 61.385, where it is a requirement in the regs to have knowledge of the aircraft systems and emergency procedures with that aircraft and the systems that are fitted, and that includes the autopilot. So enter the integration of autopilots into light aircraft. Despite those tragic lessons, autopilots are fantastic tools, and whilst there have been accidents in light aircraft as well, they can make life easier if we use it correctly. So let's have a bit of a look at what they are and how it all works, and some things that I've seen, and a few tips and tricks for you to utilize the autopilot next time you go flying. The GFC 500, 700, and similar units, S-Tech. There's a bunch of them out there that all do amazing things and integrate, especially with analog cockpits, but also glass cockpit setups. These offer us a myriad of features to simplify navigation and our workload. They intercept navigational tracks. They hold heading. They hold altitude. They gain altitude. They level off. They altitude capture. They can descend and fly in approach mode. Wonderful features, really, really great, invaluable assistance, especially on long flights or in challenging weather conditions. But with great power comes great responsibility. So pilots need to undergo comprehensive training to master autopilot operation. And this is where I want to really talk about the word autopilot. If anything, it's almost a bit of false advertising. It's not an autopilot. It's a pilot assistance. It's a pilot tool. It helps you. It does things, but it's still like a calculator. You put in the wrong question, you're going to get the wrong answer. You set up the autopilot incorrectly, it's not going to do what you expect. And I've seen this time and time again, where buttons have been pushed thinking they're doing something, relinquish control of the aeroplane, assuming the autopilot's got it, only to soon realize that the aircraft's now descending, entering a spiral dive, and is not being activated correctly at all. So just remember that it's not an automatic process. It requires pilot input and situational awareness. So let's have a look at all that now. We need to know how to operate the autopilot. So how many of you have actually taken out the autopilot manual and have a bit of a read and taught yourself how to use it? Because I can tell you right now, I've seen plenty of people that think they know how to work the autopilot and have been misusing it in many aspects. And I'm not just being picky and trying to, point fingers and say, I know better than you. I'm talking about actual operational deficiencies that are dangerous. Thinking the autopilot is doing something that it is not. All right. So these are all things that we need to be very, very mindful of and careful of. How to activate it, how to engage it, but also knowing how to intervene and take manual control if necessary, and also when to actually just not use the autopilot, like when we're low to the ground or trying to do high angle of bank maneuvers and things, entering circuits and stuff. Sometimes it's just not practical to try and get the autopilot to turn you into the circuit or into the circling area and that sort of thing. So as I've said, they can introduce risks if not used correctly. From mode confusion, right? Improper programming, deviation from standard operations can compromise our flight safety. So vigilance must be always there and monitoring for system abnormalities. Understanding failure modes or configurations where you cannot engage a mode is just as important. So just remember, autopilots do not replace human pilots. Instead, they assist us. And first one is the most obvious one, pilot inputs. They absolutely rely on pilot input to function effectively. So when we engage an autopilot and input the parameters such as altitude, heading, or airspeed, the autopilot's just going to do that. All right, but it's not making decisions or adjustments about that appropriateness of it all. It's relying on us. And this leads to the different modes of an autopilot. If we have a look with the gain of altitude, all right, some old GPS units might interface with autopilots and glass cockpits and that sort of thing, and we have assigned altitude indicators. If you've got an assigned altitude indicator, is it just that, or is it actually an altitude selection that the autopilot is going to climb to, capture, and level off at? If we're going to climb, what is the appropriate modes? Old school units would usually use a pitch selector where we can just set a pitch setting and manually climb the aircraft and then manually pitch it over to a rough level altitude, allow it to accelerate, and then engage an altitude mode. Newer ones might have an airspeed control. And there's two modes you might find on there. There might be airspeed, ASI, or it might be one called FLC, or flight level change. Essentially both doing exactly the same thing. Now, before I continue talking about that one, let's talk about descent. And that will usually be VSI, vertical speed mode. Now, you might be thinking, well, what's the difference? Why do I use one or the other? It doesn't really matter. They both make me go up and down. Well, yes, they do. But let's think about how we fly an aeroplane normally. And then we can look at one of the hazards associated with the use of the autopilot. If I'm going to climb an aeroplane, I'm going to climb at 90, 100, 120 knots, whatever it is, doesn't matter. That's how we climb airplanes. We don't climb them at vertical speeds. We'll have a corresponding vertical speed, sure, but it's the airspeed that we're typically going to be capturing and climbing out at. Now, why is that important? Well, as we climb, power reductions start to come in. If it's a normally aspirated engine, even in a turbine, eventually we start to run out of puff, run out of torque, everything else. Temperatures, we start to run out of energy unless we have turbos and the like. So the only way to maintain that speed is to gradually pitch the nose over in a bit of a parabolic climb, if you like. And that way, we're not going to get ourselves into a problem where we might stall the aircraft. If we put the aircraft in vertical speed mode, the aircraft's going to continue pitching up as we get altitude and the air thins to try and achieve that climb rate. The airplane will stall on autopilot unless it's got something like a stick shaker or a stick pusher. Well, stick shaker is just a warning, but stick pusher will recover from it, all right, which most light aircraft do not have. So it's really, really important, just something like this. And you go, well, sure, Trent, but like by the time I climb, I'm not going to be into trouble. Well, I've seen this on a night flight. I've seen a 172 with not quite full power set with a 700 or 800 foot per minute rate of climb, and the aircraft nearly stalled at night, and the student was just watching it, waiting for it to fix itself and do something until I intervened. So it does happen, and I've seen it or similar circumstance several times post that as well. So really, really important to understand what the aircraft's doing and how it's going to work. Approach mode, very much the same sort of thing. If you're flying an instrument flying, it's very, very important to activate approach mode at the appropriate time once the heading or nav course has been selected to intercept final and capture it from below. Approach mode doesn't work when you're trying to capture it from above. So these are all systems or failures. And again, talking about things last week where loss of orientation on approaches descending below lower safe, I think sometimes because the autopilot didn't do what was expected and resulted in a course deviation or descent below safe altitude. All right, which really leads us to the next point, which is monitoring. So when the autopilot is engaged, it's really, really important to continuously monitor the aircraft systems and the surrounding environment. Remember, it's just going to take you where you told it to, which could include through weather, through terrain, or more likely through airspace or restricted airspace. Right? So you, the pilot, still must remain responsible for the safe operation of the aircraft and be ready to intervene if the autopilot deviates from the desired flight path. All right, or you encounter an unexpected situation where being in control of the autopilot is no longer appropriate. And this very much comes down to your initial activation of the autopilot as well. I've seen plenty of people who have pushed altitude and heading or nav mode and left it at that and thought that was all that needed to be done, when actually they hadn't done the most important thing, which was push the autopilot on button. And this leads us to something we'll talk about shortly, which is FMA. But the next one, data entry. So accurate data entry, really, really important. And this typically comes more from something like the GPS. So if you put the wrong waypoints in, the wrong sequence, if you flight plan one thing and enter something else on the GPS, which I've seen plenty of times, the autopilot will just sequence and take you there, which potentially puts you in violation of your clearance. Just the same as being cleared for something and not updating it in the autopilot, it's going to cause you problems as well. So don't blame the GPS. That's on you. So make sure that the data entry is absolutely correct. And this includes GPS waypoint entry and confirming that we have entered what we thought in the order we thought, and the tracks and distances are all correct. Contingency management. So autopilots are designed to handle routine flight tasks, maintaining stability, but they're not equipped to handle every situation. So this preparedness to override the autopilot if it's doing something wrong. Okay, it might start climbing when you didn't think to, or not level off when you didn't expect to. Don't just sit there and watch it. Just disconnect it. Fly the plane. Aviate, navigate, communicate, and then you can worry about the automation. Why did it do that? Did you set something wrong? It might not have set the altitude that you're expecting it to level off from. It could even be, which I've seen as well, the autopilot is not actually capable of leveling off for you. You have to do it yourself. So keeping up with the aircraft system that you actually have and its capabilities, like I said earlier, really, really important. Ultimately, situational awareness is key. Keeping an eye on it, making sure it's all sorted. Who is flying the plane? Is the autopilot got it, or have you? And every time we come to a turn, waypoint change, a new clearance, we check everything, make sure it's all sorted, and that we're under control, knowing that everything is doing what it should do. And we can indeed reduce our workload and just get into a state of monitoring. Makes life easier. So the last thing I really want to talk about here, for now anyway, is FMA. And it kind of means two things. So the words or the letters, the codes that you'll usually get on either the autopilot itself, or if you've got glass cockpit up on the screen, is FMA or flight mode annunciator. This leads us really overall to another word I use, which is flight mode awareness. Who's flying the plane? What's going on? Is it doing what I'm expecting it to do? And this can come in many shapes and forms. Sometimes it can be configured, but not knowing how the GPS logic or the user interface works can lead to confusion as well. An example is Nav Mode. Now, there's essentially two types of Nav Mode. It can be navigation off of traditional VOR or localizer, or GPS Nav Mode, GPS steering, GNSS steering. There's a number of terms for it. So someone has entered a entered a flight plan into the database, or from the database rather, and the aircraft is now in nav mode. I want it to go and intercept that track, and it doesn't do anything. Sometimes, more often than not, you need to do the initial command movement, and that is set the heading bug onto an intercept course for that. And this comes because sometimes we might set a heading bug before we get cleared, or a course before we get cleared, and descent altitude before we're actually ready to do it. So the autopilot doesn't automatically just do it and follow it and go down just because you set something. You need to activate the heading change, or you need to activate the vertical speed or the airspeed climb mode before it will do the rest. So as you do that, You'll activate that mode, swing the heading bug around, and then Nav Mode will do its thing. It will intercept the course depending on how far away you are. It might not necessarily go precisely to where your heading bug is. Again, depends on the system that you're using. And it will intercept it and then fly it. And it'll give you some kind of capture indication and then a maintenance indication. And this is all going to be on the FMA or the mode enunciator. Really, really important to understand how that works. And like I said, I can't recommend enough jumping into the manual, having a read. If you've got a flight simulator that's able to replicate that particular unit, that can be done as well. And this is where my friends at Real Sim Gear, who I've partnered up with, they've got a fantastic product there. They've got the Garmin 500s, the GTN 650s, 750s, Garmin 430s, but they've also got the GFC 500 Autopilots, which in so many aircraft are very, very similar to having all the same modes as things like the G1000, and they've got the G1000 screens as well, that are fantastic desktop trainers, procedural trainers that you can use and set that up. And I'm going to be doing some things with that. I've got some of their equipment here now on my sim, which I'm going to get finished off and start making some videos and things and utilizing the Autopilot features so you can sort of see how all that works and what it does. Really fantastic gear that they make, and it really just makes learning and familiarization with that sort of equipment so much easier than just reading about it. But in the meantime, pull out the manuals, have a good read, and make sure you understand what's going on. By doing that, you'll realize it's not a substitute for pilot skill and judgment, but with good training, maintaining vigilant system awareness, and embracing safety practices like FMA, we can navigate precisely with precision, relieve our workload, get to the other end a little bit fresher, and live to fly again another day, which is ultimately the main goal. All right, guys, that is it for this week. Next week, a fantastic episode. I am interviewing Rich Stoll, author of many, many articles and books, and also really I don't know if he's the grandfather of spinning and stalling just yet, but he has certainly been around long enough to earn that title, and also develop the pair recovery technique for spinning, which you may have heard of as well, PARE. We're going to talk about that, his courses, and obviously his visit down to Queensland in June 28th. It's going to be a great episode, and look forward to talking all about it then. In the meantime, stay safe, blue skies, and remember the golden rule: aviate, navigate, communicate. Cheers, everybody.